Welcome everyone. In this video, we will talk about an interesting networking topic, which it is the MSS clamping. So, firstly, I will start step by step with a brief introduction. Then will be followed by an explanation of the MSS, and finally the concept of MSS clamping. And in the end of the video, we will capture real network interfaces and trace the packet via path in order to see the effect of the feature on the packet. So Bismillah and let's start. As we know, this is the IP packet that contains 20 bytes of IP header and data. The first few bytes of the data will be the header of the next layer protocol like UDP and TCP as a common layer for protocols. For every network, there are a maximum size for the IP packet. That size named MTU or maximum transmission unit, which the largest MTU for the Ethernet is 1500. So what will happen if a packet received with a length higher than the MTU of this network? That depending on one bit inside the IP header, which is the don't fragment flag, as you can see. The second flag in the flag section inside the IP header. If this bit is set to 1, then any packet with a higher length than the MTU will drop and an ICMP error message will be generated and sent to the source of that packet to inform it. While if this bit is 0, the packet would be fragmented to smaller size packet that's suitable to the MTU. Every fragment will take an offset number in the IP header, and the receiver in the end, after receiving the fragment, will collect this fragment and recombine it at one packet. But if one fragment is lost, the rest fragment for that packet that has been fragment will be also dropped. For UDP, the connectionless protocol that has only 8 bits header, it sends the data blindly without knowing the MTU of its own LAN or the destination network. So the UDP packet can be fragment or discard according to the flag in the header. As default for operating system, when using send for UDP, this flag for UDP usually is 0. That means a low fragment. However, for TCP, it has its own technique to solve this problem, which is named the MSS, maximum segment size. The MSS is an option in the TCP header in the extra byte after the header of TCP. After the 20 byte of the TCP, there's an option of MSS, usually sent with the first packet of the 3 handshake connection for TCP, where the client sends the first packet to connect. It will carry its own MSS, which the maximum data can be sent in his network. As this example that capture a handshake, you can see the MSS value is 1460. Then the server or the other side also will, in the second packet of the handshake, will also send his own MSS. The lower MSS will be chosen by the both sides and used as the maximum data can be or segment can be carried per TCP packet. The problem can occur when any network in the path between the sender and receiver has an MTU number lower than both the sender and receiver. That can happen for the network that use a protocol like VPN that add an extra uh, header to the packet. So they will need to lower the MTU in order to not exceed the 1500. In this case, when the packet reaches this network with the MTU lower than the packet length, then this packet will be dropped or fragment. So, and to solve this problem, we use what's named MSS clamping. In this feature, if the router enables this feature, the router will monitor the handshake packet between the client and receiver and looking for the layer 4 TCP header and check the MSS value. If the MSS value has a number higher than the network can handle, which the MTU higher than the MTU, then by the way, the MS calculated by subtract the MTU by the 40 byte, 20 for the IP header and 20 for the TCP. So after modifying the MSS with the value suited for that network, it will send it to its destination. Nor the receiver or the sender will know that the packet has been modified and the MSS has been changed. In the end, the receiver and sender will agree on the MSS that the network in the middle set, not the MS that the receiver and sender has been set. And also the modification can happen more than once. If there are more network that has lower than MTU than the first one. So the MS value can be modified more than once. In that case, the TCP packet will not be fragment or discard, and the transmission will be okay. Now to see this modification, we have this simple network that represent home network connect to the ISP and internet. At the other side, we have a holistic cloud server run in the cloud platform. In the cloud server, I will run a TCP server. From the PC, I will run the client that connect to that server. We will capture the handshake packet and see the modification. Here we have the LAN network that have MTU of 1500. This is the home router that run NAT on this interface, which mean all the packet that go out this side will have the same IP of that interface for that router. And the MTU also for this network between these two routers is also 1500. Here we have that outdoor access point which has two interface, one the Ethernet that connect to the home router and the second the tunnel interface with the ISP. Here this interface that connects with the ISP has MTU of 1480. The second will be at the Ethernet interface for this router, and the third at the tunnel interface, the point-to-point interface for the same router. And the last capture will be on the virtual private interface for the holistic cloud server. So let's start. First, for this host, we will capture the interface using Wireshark uh, and using this simple filter tcp.flag. There's already there. I already connected the access point and the cloud server using SSH and Telnet. Here I will capture the Ethernet interface for the access point, which to this port, this simple command. And here I will capture the point-to-point interface for the access point. This is the cloud server. I captured the visual interface. Then I install the TCP server here and start the connection. Stop capturing. Need more capture. Now this is the capture for the handshake and the host. As we see, this is the first packet. If we go to the layer 4 information, this is the layer 4 information. We will go to the option part. This is the option, and you can see that maximum segment size here is 1460, and that normal is the MTU subtract by 40 byte. Now we will see at the internet interface here. It must be the same number because both network has the same MTU. Let's see. This is the packet sent from the PC to the server. The same number 1460. But if we can see the capture at the point-to-point interface, you can see the MS is 1440. There's a 20 byte difference because the MTU is 20 byte smaller than the MTU of the LAN network. So this is the first modification on the packet of the TCP packet for the MSS section. Now we see the cloud server what we received. This is the public IP of the ISP. This is the visual IP, private visual IP for the server. As you can see, the MS reached the server, the cloud server with 1400, which it is more or less that because the requirement of the cloud platform network that reduce the MS more, so it is completely different as we sent here. We sent it as 60 and at the end become this number. The same thing happened to the packet that sent from the server to the this computer, which the server send MS with that big number because it's not Ethernet network but it's virtual network, and it seemed like that. But also it's modified until we reach us with the same size 1400. Now let's try something else. I will modify this MTU for this network too. We will see that the packet will be modified 3 times. The MS will be changed 3 times in this path. Change it to this number and save it. First, let's clear the old capture. Old capture again. TCP server and connect. um, Forget. For the host, of course, the MSS will not change because it's the same. But if we go here for the Ethernet interface that we change the NTU, you can see the MS now it's changed to 50. Because we reduced the NTU by 10, the MSS also reduced by 10. For the point-to-point and the realistic server will be the same as before. For the point-to-point also will modify to this number, and in the realistic server the number will be this. And that's all for this video. I hope it was useful, and if you have any other topics you want me to talk about and explain, feel free to share it in the comment section, and thank you for watching.